Way 45, nonpolar covalent bonds. So when you have two of the same nonmetals bonding together, they're going to be sharing electrons equally. And the reason why is because if each atom has the same electronegativity, they're both pulling the electrons, the valence electrons, with the same amount of force. If you have two different nonmetals, there's going to be unequal sharing of electrons, meaning one of the nonmetals with the more electronegativity is going to pull its electrons closer to it. That pull of negative electrons toward that atom is going to result in unequal sharing of electrons. That unequal sharing results in a slight positive charge and a slight negative charge in that molecule. So whenever you see two or more of the same nonmetals sharing or bonding, that's a nonpolar covalent bond. It means the sharing is equal. Or if you have two different nonmetals, it's going to be unequal sharing, and it's going to result in a polar molecule because there are two different nonmetals. Let's try some problems. Which Lewis electron dot diagram represents a molecule having a nonpolar covalent bond? Please note that anytime you see brackets, that indicates an ionic bond, so you can eliminate that answer. And in order for it to be nonpolar, it means the electrons are being shared equally between two of the same nonmetals. So which of these answers features the same nonmetal? Answer choice 1. Note that 2 and 4 result in unequal sharing of electrons. Chlorine has more, sulfur has more, so that side of the molecule is going to be more negative, and the hydrogens, and in hydrogen in most cases, will be positive. So these are polar covalent molecules. Answer choice 1 is a nonpolar covalent molecule. Number 3 is an ionic compound. Which molecule has a nonpolar covalent bond? Again, look for the answer choice, which features two of the same nonmetals in order for it to be nonpolar. So the only one that features that is answer choice 1. All the other answer choices result in unequal sharing of electrons where one atom has more electrons on it compared to the other atoms, and that results in a slight negative charge. So 3, 4, and 2 are all polar covalent molecules. Carbon has three naturally occurring isotopes, C12, C13, and C14. Diamond and graphite are familiar forms of solid carbon. Diamond is one of the hardest substances known, while graphite is a very soft substances. Diamond has a rigid network of bonded atoms. Graphite has atoms bonded in thin layers that are held together by weak forces. You should be thinking allotropes when you read this problem. Same exact substance with different chemical properties because they are in different chemical structure. Recent experiments have produced new forms of solid carbon called fullerenes. One fullerene, C60, is a spherical cage-like molecule of carbon. Identify the type of bonding in a fullerene molecule. The type of bonding present in a C60 molecule. Notice that here we have carbon bonding with itself. It's the same nonmetal. Therefore, your answer should include a nonpolar covalent bond. The reason why, because carbon and carbon are the same nonmetal, and they always form nonpolar covalent bonds. These electrons get shared equally between each carbon atom. Which molecule contains a nonpolar covalent bond? Again, when you see nonpolar covalent, same nonmetal, each sharing the same electrons. So the only answer choice that features that is answer choice 3. The bonds between hydrogen and oxygen in water molecule are classified as Note that hydrogen and oxygen are both nonmetals, and whenever we have two different nonmetals bonding, we're going to have a polar covalent molecule. So the answer choice is 1. The electrons in a bond between two iodine atoms are shared because we have two iodine molecules and they're both the same nonmetal. It's going to result in equal sharing of electrons. Therefore, you can eliminate 3 and 4. And the bonding has to be nonpolar because it's perfectly symmetrical. So answer choice 2 is correct. So remember, when it comes to nonpolar covalent bonds, it's always two of the same nonmetals, resulting in equal sharing of electrons. Polar covalent molecules feature two different nonmetals where the sharing of electrons is unequal, and one of those atoms is going to be negative, the other one is going to be positive. Thank you for watching.